For the Capstone Kaggle data analysis project, I chose to analyze the 2016 Seattle Airbnb dataset. To choose what metric to focus on, I first printed the info for the dataset after loading it into a Pandas data frame. This displays all columns and how many non-null values exist for each column. I did not want to use metrics for which there existed many null values, because they would not give accurate insights. Initially, I thought square footage would be a good metric to calculate value, but a large number of values in that column were null, so I decided to use other values instead, like the number of amenities, the number of bedrooms, and the number of people accommodated. The data cleaning performed on this dataset includes dropping columns with a high number of null values, removing non-numeric characters from price columns, converting numbers to floats, converting dates to datetime objects, standardizing the street column by replacing abbreviations, and filling null values with other values like 0 where appropriate. I also cleaned the amenities column by stripping and replacing characters and converting it to a list. Some feature engineering tasks performed on the dataset includes adding new columns based on other columns available. I created a seasons column for the calendar dataset and a seasons available column for the listings dataset to display the seasons each listing is available. I also created columns for the number of amenities, the cost per amenity, cost per accommodation, whether the listing requires a deposit, if internet is available, and the years a host has been a host. This data was used for aggregation, such as the overall availability of listings per season, the overall average rating for each host, and the value of the listing based on the price compared to the number of amenities, accommodations, and rooms. For visualizations, I thought it'd be interesting to see if host experience years impact guest satisfaction by looking at host years versus average host ratings. While the scatter plot shows that most hosts receive ratings over 80%, the plot does show a slight correlation with hosts with over 6 years of experience and ratings over 80%. The plot also shows more clustering at fewer than 7 years. This may indicate there are fewer hosts that host past 7 years. The next chart is a simple bar chart, and it shows the overall season availability of listings. The most listings are available in autumn, while winter offers the fewest available listings. The next figure is a heat map, and it shows what factors are most strongly correlated with higher review scores. If we go past the scores related to review metrics, we can see that the number of amenities has a strong correlation with review scores, as does the number of rooms, the cost per accommodation, and the host. The next plot is a price distribution. This shows where a majority of listings are priced, which is at the blue bar. And because the blue bar is taller rather than shorter, it demonstrates a higher variability in listing price. Most listings are under $800, with a few outliers over. The last scatter plot shows the number of amenities to the listing price. From the plot, we can see that more amenities does not necessarily mean a higher price. Listings with 12 to 22 amenities tend to have a higher price than listings with fewer or more amenities. For my web scraping project, I scraped baseball statistics from the Baseball Almanac. The data I collected was the hitting and pitching leaderboards for each year for each league. I also collected the team standings for each year and league. A major obstacle I had to overcome when scraping the data from these tables was span row values in the HTML tables. Initially, I tried to overcome this by tracking if the last row had a span row value. Using this method was not successful, and ultimately, I decided on the Pandas read HTML method, which automatically handles span row values. I thought this would be a better option than excluding the data for those rows and having missing data points. There was quite a bit of data cleaning needed for this data as well. Some of the column names in the HTML tables were different, so I had to fill in those values from the equivalent columns and then remove the redundant columns. I also had to clean some of the statistic, player, and team names. The data I scraped was then loaded into two CSV files, baseball stats and team standings. For the dashboard, I chose to make an application using Plotly Dash. The first chart shows statistic averages for each player, chosen by a drop-down menu. The next chart displays the average statistics per team. Here we can see the average statistics for Boston. And here it is for Chicago, Philadelphia, and Baltimore. And this is over all the years. The next chart shows team standings for the chosen year and the chosen league. It displays the team standings, or wins versus losses and ties, per year for the selected league. Thank you for listening to my presentation.